All right, so log equations finally. Yes, you should still be paying attention for reasons. All right, so 2 times the natural log of x plus 3 is equal to 7. All right, so notice that x plus 3 is not in parentheses, so that plus 3 is outside the log. So before I can deal with getting at that x, I have to deal with that natural log, I have to deal with that times 2, and I have to deal with that plus 3. So the outermost operation here is the plus 3. So that is the first thing we're going to cancel. I'm going to minus 3 to both sides. So now this is 2 natural log x is equal to 4. 2 times, so we're going to use division now. So now we have the natural log of x is 2. Now, the way the book describes this is they have, here's the log equation, here's the equivalent exponential equation. Look, you can transform between the two. You can. So if you want to do like the whole swoopy arrow, e to the second equals x, you can do that. I just prefer to think of them as functions and use an inverse function. So my inverse function here is the e as an exponential. So e to the natural log of x equals e to the second. So x is e squared. Now, if you had this on WebWork, they should take that, but we know how WebWork is with shoulds. So e to the 2 is 7.38905.6, blah, blah, blah. If WebWork gave you that, it should take e squared, though. E squared would be the more precise answer. All right, now we got an even shorter one. 6 plus the natural log of x. So before I can deal with natural log, I need to deal with that 6. So minus that on both sides. And now I have the natural log of x equals 4. And now we use our exponential as the inverse of the natural log. And now we get x is e to the 4th, which is some number that's even bigger. $54.598. Now, these are log equations. So we want to look at our number, make sure it fits in the equation. So remember, logs have restricted domains. I cannot put a negative number into a logarithm equation. Generally, if you solve and only get one number, that number is probably a solution, so you're probably safe. But it is still something you should at least think through. 7.38 is positive, so I can take the natural log of it. 54.59 is positive, I can take the natural log of it. You should always check these, just to be sure. Now, it's not necessarily if I get a negative number, I throw it out. Over here on the number 10, if I got negative 1/2, negative 1/2 plus 1 is positive 1/2. So that would be a number that's permissible in the domain of logs. So don't just chuck a number out because you're like, oh, we can't put negatives in logs. The inside of the log is 2 minus x. You can put all the negatives in that log. All right, so 2 times the natural log of 6x is equal to 7. So just like normal, 2 times is our outermost operation. So we're going to start by dividing by 2. 2 times thing divided by 2, they cancel. So our thing is now natural log of 6x equals 7/2. Now we use our e exponential as the inverse of the natural log. So this is now just 6x equals e to the 7/2. Then last step, we divide by 6. You can also write it as 1/6 times. Either one works. Now, just to be safe, I sometimes get antsy about putting the divide by 6. Like, what if it still thinks it's part of the exponent? If you don't have that natural display, it can be hard to tell. So you can always put parentheses around the entire top or entire bottom of any fraction. So I'm going to do that here just to be safe. E to the, it opened, so then 7/2, close and close, divided by 6. So rewind to the original. 5.5 times 6 will be positive. I can take the natural log of that, so that's fine. Cool. All right, lay it again, Sam. It's 2 times the natural log of x plus 1 equals 10. So we divide by 2, divide by 2. So now the natural log of the whole x plus 1 is equal to 5. And now our e exponential comes to play, cancels out that natural log. So now I have x plus 1 equals e to the 5th, minus 1 from both sides. So x equals e to the 5th minus 1. Just to be safe, let's write the parentheses that we know we should write around the 5. E to the 5th, close, minus 1. Otherwise, you'll just get e to the 4th, which is not the correct answer. So this comes out to be 147.413159. Yeah, it's like that, 413. All right, if I put 147 plus 1, 148 something, I can take the natural log of that. It should work. All right, I believe it's just one more after this where the log equations get real crazy, but stay tuned. You're gonna want to see it.